Hey everyone, I hope you're having a really good week. Today we're going to move on to Unit 8. And Unit 8 is kind of continuing about what we were talking about in Unit 7, solving quadratics. So that's why with the snow week and everything, I didn't really go back and make us redo all that work because we're kind of going to go over most of that again. So we're talking about quadratics. So for today, let me go into student view real quick. This looks like what you are seeing. Okay. And we're done with Unit 7, so you can collapse it. As long as you've taken the test for Unit 7, you're good. So you've got new journal slides for Unit 8, so be sure and grab these and make a copy of this file or add them to, if you're doing the digital journal, then make a copy of them. Actually, this is not on here. This is not on here today. I don't know why that's showing up. That should not be showing up. This should be all you're seeing. But grab those journal slides for Unit 8. I'm going to go over them today. We're going to talk about some of them. We're going to talk about quadratics. And these are the equations that have the x squared in them. That's where the quadratic comes from, because it has that term that has x squared. We're going to talk about the graphs of them, what they look like. And then be ready tomorrow because we are going to start a project. And this is going to be a major grade, this project. It's one of our test grades. It's not going to go onto the test grade for this 9 weeks. It'll be next 9 weeks, but it is going to be due before we go for spring break. It's going to be due on March the 5th. So I'm going to give you all excuse me, like a week and a half to work on it. But we're going to be using Desmos a lot in this unit. So let's get started. Go ahead and grab your journal slides if you haven't already. Go here and make a copy of the file. And I'm going to kind of introduce you to quadratics. And I want you to do, there's a Desmos activity called Will It Hit the Hoop? It's pretty fun, actually. It's talking about basketball and making predictions of if a basketball is going to go in the hoop. So we're going to figure out that quadratics have a lot of real world applications. They apply in real life. Anytime you're talking about projectile motion, rockets, throwing a ball, somebody jumping up in the air, quadratics model that movement in the air. And so that's kind of what the Desmos activity is going to introduce you to. So I'm going to go ahead and pull up the notes on my iPad here. Okay, I don't know why it's not going to do it full screen for me right now, but I'm going to leave it like this. So here is your Unit 8. It'll catch up with me here. Journal notes. Okay, so here's everything we're going to learn in Unit 8. And some of this we actually have already learned. It's just mentioned again, but these are our objectives. We're going to talk about domain and range again, but we've already talked about domain and range. We're going to talk about some transformations again, which we've done with lines. And then we're going to talk about using the calculator to get equations, which you're going to find, we've done that before with lines. Most of the things that we're doing, we've talked about with lines. So we want to start by figuring out, okay, what are the key features? So with lines, we had slope and we have y-intercepts and x-intercepts. But there's actually some more parts here. So if you're given a graph like this, and it says to look up these words, but I'm actually going to help you fill in the graph here because I want to make sure this picture that you have it filled in correctly. So if you want, you could draw a rough sketch of this graph if you're doing this on paper and draw this U-shaped. So these quadratics, and these are things that have the x squared in them, quadratics. So you need to think the things that are in this form, ax squared plus bx plus c, the same types of equations that we were factoring before. They look like this U shape when you graph them, which we saw in Unit 7 because we were graphing them and finding the x-intercepts to find the solutions, right? Yep, we were clicking on them. We saw it was this U shape. So let me zoom in a little bit here. So we call that U shape a parabola. It's not a parabola, okay? So it's a parabola. The general U shape is called a parabola. Now the vertex of the parabola is this point at the bottom down here. It's either the lowest point or the highest point because sometimes this parabola is tumped upside down. Instead, I call this a valley. Sometimes it looks like a mountain. Then right here where it's crossing the x-axis, well, we call that x-intercept. But if you remember, there was another words that meant x-intercepts. Zeros and roots. Remember, we talked about that. They also mean x-intercept. And then this point over here, where it's actually crossing the y-axis, is still the y-intercept. And then this imaginary dotted line they've drawn through the middle here, this is where you could take the shape and you could cut it right in half. So if you draw that line through there, you're actually cutting it in half, and it's called the axis of symmetry because it's symmetric. I'm not going to have enough room to write symmetry. It's symmetric. Remember, symmetry means you could cut something in half and you could fold it over, like take a piece of paper and fold it in half, and both sides would be equal. So we're going to use maximum and minimum down here at the bottom. So the vertex, so we're talking about, let me grab a different color here. We're talking about this point down here. The vertex is called a blank when it's the highest point. Well, naturally, it's called the maximum if it's the highest point. But for this one, the vertex is not the highest point. Notice it's the lowest point on this U-shaped graph here. So when it's the lowest point, we call it a minimum. And then the solutions, we've already talked about this, are the x-intercepts. So we have to keep that in mind. We learned that last unit, what we tested on yesterday. And solutions to quadratic equations are also called roots or zeros, either one. So just a little more vocabulary to remember there, okay? All right, so let's go down here. So you can find the equation for the axis of symmetry. All you have to do is use the formula x equals negative b over 2a. Now, where do you get the a and the b from? Well, remember our equation's in this form, ax squared plus bx plus c. So you would use the a and the b. You wouldn't need the c value. But you would use the a and the b value from this equation, and you could find the value for the axis of symmetry, the x value of the vertex, which is also the axis of symmetry equation. Because if you notice here, it's always cutting it straight through. What's it going through? Right here. It's going through the x-axis. So the axis of symmetry is always the x value of the vertex. To find the vertex, you could do all this complicated stuff right here, but guys, if we have something easier. So to find the vertex, we're going to use Desmos. It's the easiest thing to do. If you have an equation, just use Desmos. Type it in Desmos and then look for the vertex. You can click on it in Desmos. Now, if your a value, the number in front of x squared up there, okay, so if it's greater than 0, if it's positive, then your vertex is going to be a minimum. It's actually opposite of what you would think, but you'll be able to see this on the graph. And if it's less than 0, then it tumps the thing over and it becomes a maximum, which you'll see some examples. To find the y-intercept, you could substitute in 0 for x and solve for y. But again, or you could just use Desmos, which is what I suggest that you do. So let's look at a couple of examples here, and then I'm gonna let you work a couple of examples. So for the first one, y, let me make this a little bit smaller here and get my thing. Okay, perfect. Now let me pull up Desmos on another screen over here. All righty. Let me see if I can get these side by side so we can see them. See a little bit better. Okay, so I'm going to type this first one in. Y is equal to x squared, and you can type the y equals. So x, now if you can't remember to do shift 6, then you can come down here and hit the squared here. Minus 2x minus 3. So here is our U shape. Do you see this? So they want you to first identify the axis of symmetry, the vertex, and the y-intercept. And then tell them, is it a minimum or a maximum? So we're looking for the axis of symmetry. We want to know the vertex. And we want to know the y-intercept. Okay, well the axis, let me let my computer catch up here. Oh, it's all like digital, pixelated too. That's weird. Okay, so we have, see how we can click on all this stuff right here? Desmos is going to let you click on all these values. Now this is the x-axis, so these are the x-intercepts, which are also the solutions. So the solutions would be -1 and 3, and the roots and the zeros. But it didn't ask me for those. It wants the axis of symmetry, and it wants the vertex. Well, the vertex is this lowest point here. So the vertex for this one is 1, -4, which happens to be a minimum for this one. I call this one a valley. That, you can't even read that. I don't know what I'm writing over here. The y-intercept, well, that's where it's crossing the y-axis here. Oh, well, that's this point. That's 0, -3. Now, the axis of symmetry, the equation is always an x equals equation. And it's always the x value of your vertex. That's where it would cut it right down the middle, right through the x-axis right there. So that's going to be the x value of 1. So your axis of symmetry equation is always the x value of your vertex. Okay, so let's do this again with the second one. I'm going to let you do the third one. So I want my axis of symmetry, I want the vertex, and I want my y-intercept. Okay, while my iPad's catching up, I'm going to go ahead and type this one in. So we have y equals -x squared minus 4x plus 5. Oh, so this one's different. This one has a maximum this time. It looks like a mountain. And again, I'm really interested in my axis of symmetry. The vertex is that highest point. So the vertex for this one is -2, 9, and now this one is a maximum. It's not a minimum this time. It's the highest point. My y-intercept is where it's crossing the y-axis, which is 0, 5. And then my axis of symmetry is always an x equals equation, and it's just the x value of your vertex. So I don't need the y-intercept to find the axis of symmetry. It's x equals, well, for this one, -2. Because at x equals 1, -2, right here is where I could cut this thing in half, and it would be equal on both sides. So x equals -2. That's it. Okay, so we're going to use this information here, and we're going to start our project tomorrow. So you do number 3 on your own. Fill that one out. And then I'll come back tomorrow with a video, and I'll explain. I'm going to assign the project to you, and I'm going to give you a video on what you need to do for it.